Hello, today's video will be instructional. In the initial review I had with this WEN YX-961TR, I made a passing mention about an issue I found with the possibility of having the meter correctly zeroed. And I suspected that to be mostly due to a mechanical cause. Surprisingly or not, the mechanical cause has been found out. But first, let me tell you how I took apart the meter. The backside obviously had to go. It was screwed in place in a single point. Then I thought about taking out the front cover, the transparent front cover. As you can see in those two sides, there were two hinges that fixed or secured the front part. If you place enough force in order to move them out of the way, which means in this case that you have to turn them towards the inside, and you found one that has slightly more weight than the other, it means that slowly you can take out one of the hinges and then focus your effort slowly on the other. You have to consider the fact that the plastic may break, so you have to be very careful, pay a lot of attention, and be very patient, because otherwise you may break apart the front cover and there is nothing that could be done to salvage it. And since it's made out of polycarbonate, it's going to be quite brittle, so it has a strong risk of breaking. And even if you place some sort of glue after all, it's not going to withstand very well due to the difference in mechanical stiffness between the glued parts and also the strong force that is being exerted in these two single points. So being careful actually saves a lot. So I pried apart both of these hinges, first one then the other, until slowly I could lift this upper part. And what I found was entirely surprising, but it shouldn't have been. If you can readily see over here, I don't know if you notice, okay, that's in focus, there is a slight protrusion or lip from the plastic molding. And surprisingly or not, that shouldn't have been the case. If you notice over here, this has an irregular shape. And the reason for its irregular shape is immediately apparent when you think about how it happened. Well, this part is bendable. It's part of the initial molding that should have been scraped about when the molding was done. Because when you remove a plastic piece from a molding, it's obvious that parts of its initial molding may stick to it. And this means that this issue happened. In general, plastic parts have to be finished or the molding has to be very good so that these effects are minimized. However, this wasn't the case over here, and we've got an excess piece of plastic that should have been taken out. And if we are going to take out this piece, clearly we are going to stand much better in this respect. And what actually happened? This extended protrusion actually got on the inside part over here, if you can hopefully see, and extended beyond the center indentation. And this meant that it hit the poor soldering blob that you have over here. So it means that the initial leeway that should have been there due to different positioning was off, and those two parts, the plastic part that protruded through this hole, reached and hit this solder blob. And this made the pointer not to have full deflection when there was a slight change in the zero position. It's surprising, but this is what happened. And if you wonder how can this happen just by having a certain angle difference, the reason is very simple. This part also has a slight bend to it, which means that when it moves, it doesn't move without affecting the angle at which it hits something. So it means that due to the leeway that happens in here, compounded with the plastic lip, it meant that there was a certain position where those two parts would make contact. And this meant that the meter could not have a full-scale deflection when the zero position was adjusted. This goes on to show how important quality control must be for this precision equipment. It doesn't matter how well the rest of the device is being built if over here they skimped on quality. So I will look again and make sure that the plastic part is safe from any sort of debris that might have entered, because after we place the front side, any sort of dust is not going to be able to have any way of being released from here. So we are going to slightly blow, although this may not be entirely recommended, and blow so slow that it doesn't affect too much the pointer. Make sure that we are roughly in a position that could make the protrusion make a good contact with the other side. Probably one of the solutions would be to slightly affect the initial zeroing, so that we know that this part is straight, and this one should be just as well placed in the straight position. So probably this means it's to be aligned like that. Okay, we make sure that we reach okay. I think this is as good as we get in terms of orientation. I tried to turn it until I saw that part as being flush and the plastic part as being flush as well. So probably there could be a slight adjustment. Okay, I think it's straight. The idea is that if you don't align properly the two sides, when they enter, it may hit the metal part and bend it further, which is not what we want to do. And this means that we have to make sure that it enters smoothly and there is some leeway. Okay, and right now I think we can readily press up until it clicks. We make sure that we are well aligned. In this case, it's clear that we are close to the ideal position, but still we have not reached it. And then slowly but surely we're going to apply pressure up until it reaches the current position. As we can see over here, it doesn't seem to be entirely okay. I think I know why this may happen, and it is due to the lip that we have on the other side. Okay, I think I have to take it again and attempt it by making sure I place the front side first. So probably this is what I will try to do, because I think this lip has to go beneath the plastic housing. Okay, and right now it seems I made a good contact, so I'm going to apply more pressure on the lower side, and hopefully I will be centered enough not to affect. Let's see, has it entered? We never know, but we will apply some movement over here to make sure that, okay, we have proper deflection, so probably it did not stick or bend the adjusting hole. Okay, I think it offers enough adjustment possibility. All right, so right now we make sure that the meter is leveled, and we will make the measurement of this particular battery that you have seen as having almost around 1.5 volts. I'm interested to see if it is correctly measured right now. Okay, to the camera it looks like the zero position is well placed, but okay, I think that is as good as it's going to get. So we are on the 2.5 volts range, and let's see how close it is to the actual value we are expecting. Sorry. Okay, to me it reaches somewhere along the line of 1.495 volts. So this is quite close to the actual value I measured with multiple digital multimeters that are close to a spot on 1.5 volts. So 1.495 is close enough, and for an analog multimeter I think that this precision is quite reasonable. It could have been a bit closer to 5, and I'm pretty sure, and I have noticed the Olson AM345 as reaching almost 5 volts, so clearly there could have been a higher precision in measurement. However, in this case I think that it's well enough. Again, I wasn't expecting high performance, however I wasn't expecting a poor performance, as I have noticed, and such a trouble in reaching correct adjustments, but there you have it. That's the manufacturing quality most devices have. So if you buy such a multimeter, be prepared to at least pay attention to some clues that at least testing was not done up to the standards we expect. So hopefully, I hope you enjoyed the video. I think it was instructional, and see you next time. Thank you very much for watching.